Beneath the deserts of New Mexico and the elevated valleys of Colorado, a quiet force is at work, slowly pulling North America apart. Most people travel across this region without ever realizing they've crossed one of the continent's most remarkable geological features, a vast stretching scar in the Earth's crust known as the Rio Grande Rift. At first glance, the landscape seems ordinary: valleys, mountain ranges, and dry basins shaped by rivers over time. But hidden below the surface lies something far more powerful: a deep tectonic fracture. Though it lacks the fame of the San Andreas Fault or Yellowstone, the Rio Grande Rift may reveal clues about the continent's distant future. Some scientists believe this rift represents the earliest stage of a process that could one day split North America into two separate landmasses, eventually forming a new ocean. Deep underground, the crust is slowly pulling apart, millimeter by millimeter, driven by heat, rising magma, and the same forces that once tore apart ancient supercontinents. These changes won't happen in centuries, but over tens of millions of years. Still, the rift serves as a reminder that continents are not permanent. So what if the Rio Grande Rift is the beginning of North America's eventual breakup? Could these quiet desert landscapes mark the first step toward a continent divided in two? Let's explore. And if you enjoy content like this, don't forget to subscribe and like the video. It's the best way to support the channel. The birth of a continental tear. The origins of the Rio Grande Rift trace back roughly 25 to 35 million years ago, during a time of major tectonic change across North America. Earlier in the Cenozoic era, the continent had been under intense adduct from the subduction of the Farallon Plate beneath its western edge. This compression helped form massive mountain ranges, including the Rockies. But as the Farallon Plate gradually broke apart and sank into the mantle, those compressive forces began to fade. The continent started to relax, and in certain regions it began to stretch. The area that would become the Rio Grande Rift was especially vulnerable. Its crust was thinner and warmer than surrounding regions, making it easier to deform. Beneath it, hot mantle material rose upward,
weakening the lithosphere from below. As tension increased, long parallel faults formed. Blocks of crust dropped downward between them, creating elongated basins. Over time, these basins, like the San Luis Valley, the Albuquerque Basin, and the Espanola Basin, became defining features of the region. Volcanic activity also played a key role. As the crust thinned, magma found pathways to the surface. In northern New Mexico, the Jemez volcanic field produced massive eruptions, including the formation of the Valles caldera, one of the most significant volcanic structures in the United States. Further south, regions like the Taos Plateau and the Potrillo volcanic field were shaped by repeated basaltic eruptions, leaving behind vast lava plains and scattered cinder cones. Rifting is not a sudden event. It begins with small fractures and subtle depressions, but over millions of years, it can evolve into vast valleys, volcanic regions, and eventually entire oceans. Today, the Rio Grande Rift stands as a mature yet still developing system, one that mirrors the early stages of continental breakup seen elsewhere on Earth. Its formation marked a turning point in North America's geological story, and that story may still be unfolding. Evidence of rifting. Despite the calm appearance of the region, the Rio Grande Rift is far from inactive. Geological evidence shows it is still slowly expanding. Current estimates suggest the crust here is stretching at a rate of about 1 to 2 millimeters per year. While that may seem insignificant over millions of years, this steady movement adds up. Seismic activity provides further proof. The rift experiences frequent small earthquakes, particularly along active fault lines where crustal blocks continue to shift. One of the most intriguing areas is the Socorro seismic anomaly in central New Mexico. This region experiences earthquake swarms, ground uplift, and contains a large body of magma located roughly 19 kilometers beneath the surface. Measurements show the LR there rising by about 2 millimeters per year, strong evidence of ongoing magmatic activity. In other parts of the rift, geothermal features reveal the heat below. Hot springs, fumaroles, and underground reservoirs are scattered throughout the region, offering both natural beauty and potential energy resources. All of this confirms one thing: the Rio Grande Rift is not a relic of the past. It is an active system continuously reshaping the crust, slowly but persistently. The North American split. If the Rio Grande Rift continues to evolve over tens of millions of years, the consequences could be dramatic. In a distant future, the rift could deepen and widen enough for seawater to flood into its basins, forming a long inland sea stretching from Colorado to Mexico. As the LARD continues to pull apart, volcanic activity could intensify along the rift, creating chains of volcanic islands or ridges. Eventually, the crust could rupture completely. New oceanic crust would begin forming, and North America could split into two distinct landmasses. The western portion, potentially including parts of Colorado, New Mexico, Arizona, and Utah, might slowly drift away from the rest of the continent. The Rio Grande Rift would then become a new ocean boundary. Such a transformation would reshape ecosystems, alter climates, and redefine geography. New coastlines would emerge, and mountain-building processes could intensify along the edges of the forming ocean basin. Over even longer timescales, drifting landmasses might collide with other tectonic plates, giving rise to entirely new mountain ranges. While this scenario may seem extreme, it's not without precedent. The Gulf of California began as a rift, much like this one. Today, it is a narrow sea formed by active seafloor spreading. If it happened there, it could, under the right conditions, happen here. Complexities and uncertainties. However, not all rifts succeed. Many begin with clear signs of development, but eventually stall, becoming what geologists call failed rifts. One well-known example lies beneath Lake Superior, the mid-continent rift, which nearly split North America around 1 billion years ago before stopping. Today, it remains buried and inactive. The Rio Grande Rift could face a similar fate. Its future depends on the tectonic forces acting upon it, and those forces are constantly changing. Plate boundaries may shift, new subduction zones could form, mantle may weaken or redirect. Any of these changes could slow or completely halt the rifting process. Additionally, the current rate of extension, just 1 to 2 millimeters per year, is relatively slow by global standards. At this pace, it could take over 100 million years to reach advanced stages. Predicting conditions that far into the future is extremely difficult. Scientists also continue to debate what's driving the rift. Some suggest it's due to the gravitational collapse of the elevated Colorado Plateau. Others point to deeper mantle dynamics or lingering effects from the subducted Farallon Plate. These competing theories highlight just how complex and uncertain the system really is. Future outlook. The idea that the Rio Grande Rift could one day divide North America is both fascinating and scientifically plausible, but it exists on a timescale far beyond human experience. Civilizations rise and fall in thousands of years. Even the entire history of modern humans is insignificant compared to the time required for continents to break apart. Whether this rift continues, stalls, or transforms into something entirely different is a question that will be answered long after humanity is gone. Still, thinking about such possibilities has value. It reminds us that Earth is not static. The landscapes we see as permanent, mountains, rivers, coastlines, are constantly changing. Continents drift, oceans open and close, volcanoes rise and fade. The Rio Grande Rift offers a glimpse into that ongoing story. It may remain a modest valley system, or evolve into an inland sea, a volcanic boundary, and eventually a new ocean. In the far future, North America as we know it could disappear, replaced by two separate continents slowly drifting apart, not as a sudden catastrophe, but as a slow, inevitable transformation, a process as old as the planet itself. And whether or not the Rio Grande Rift fulfills that destiny, its story reminds us of one powerful truth: the Earth is always changing, and we are only here to witness a moment of it.